Okay, everyone, today we're going to get into some of the basic anatomy of the respiratory system and the functions of respiration, the 4 stages of it. So before we do get into the 4 stages of respiration, I want to see if you can identify this anatomy of the respiratory system. I will give you a handout that has this diagram on it tomorrow. But for now, let's just see what you know and don't know. Let's start with number 1 and work our way to number 11. Can any of you tell me what is number 11 pointing to? Raise your hand. You can't see 11. I meant to say 1. Huh? Nasal cavity or parasinus cavities. We'll just say nasal cavity. Fun fact. Your nose is the only visible part of your respiratory system. And your nasal cavity is much greater in size and volume than your next cavity is, which is what number 2 is pointing to. Kate, you know what number 2 is pointing to?
Your mouth.
Mouth or oral cavity. When you open your mouth, we can see inside. When your lips are closed, we can't see inside. But can you close your nostrils? No. Unless someone can flare your nostrils. Anyone know how to flare your nostrils? Careful, don't pull out a booger. We'll learn about boogers in this class too, by the way. Snot and all that. But for now, let's just go with basic anatomy. All right, number 3. Actually, let's do number 7 now. What do you call the back of your throat where your 2 sinuses, or your 2 cavities, I should say, meet? This is shared by your respiratory system and your digestive system. Esophagus is where food travels from your number 7 to your stomach. So it's not it. Anyone else? Not the larynx, but it rhymes with larynx. The pharynx. The pharynx is also perhaps called the throat. And there are 3 parts to the pharynx that you'll need to know. This is going to come in handy in a few days. I have the yellow, the blue, and the pink part. There are different parts of your pharynx. Let's start with back here, the uppermost, the most superior. This is called your nasopharynx. I know you have nothing really to write on today, but I'll get it to you tomorrow. Your nasopharynx is the uppermost portion of your pharynx. It's the back of your nasal cavity. Below your nasal pharynx, I think you might be able to figure this out. What do you suppose the back of your oral pharynx, or excuse me, your oral cavity is? It's not oral pharynx, but it's close. Nasopharynx. What do you think the back of your mouth is called? Oropharynx. And then the part that's just above your larynx is going to be called your laryngopharynx. Those are 3 portions. Remember that it goes naso, oro, laryngo. And then number 3 is your voice box. You generate a voice by air passing through it, and you can control how much air is going through it. If Lance is trying to run away from his last class in AP Bio when he's a sophomore and he and David are the only 2 people in class, and he thinks he can just slip by, and then I have to say, Lance! What? Go back to class. Okay. But that's just a hypothetical, right, Lance? Right. I can control how much air goes through my voice box or my larynx to generate a voice. So I can sound like Darth Vader, or Lance, or I can sound like Smeagol. Silly sophomores. I can sound like Elmo. La, 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 la. I can sound like myself. Hey, everybody, welcome to class. I can sound like Mackenzie. Hi. I don't know, that's a pretty horrible impression. I can sound like Alex. You can make different voices. People are very good at that, better than me, just by controlling how much air can flow through it. Keep that in mind. That's a mastering question. That's why I'm placing a lot of emphasis on this. How do you control the sound of your voice? By the amount of air and the force of air that passes through your larynx. That's what this one is, the larynx. It is your voice box. We kind of call it a box. It is made completely of hyaline cartilage. And your thyroid wraps around it. Next is your windpipe, also made of cartilage. Number 8. I'm going to take a swing at what it is. It is not your esophagus. That takes food to your stomach. This is your trachea. If any of you want to be a nurse or a medical professional, if you have to, I hear the story all the time because my fiance and future sister-in-law are nurses. They say, I had to go to the hospital, or in my night shift last night, I had to trach this guy. It was so hard. Like, what do you think they mean by that? A trach a guy? They had to shove a breathing tube down his throat. They had to trach him. So your trach is your windpipe. And then your windpipe branches off into number 5. What are those large tubes that fork into your big breathing organs? Number 5, bronchi. It's really number 5 and 9. I don't really see a difference between the two. Okay, we're going to skip 4. You probably figure what it is. What do the bronchi branch off into? They're even smaller pathways, smaller than bronchi, bronchioles. If you ever had bronchitis, you have inflammation of your bronchi. Number 11 is the end of the line. It's where the gases you inhale mix with the blood that's circulating through your body. What are these air sacs? You want to know? Alveoli. Oops, spelled that wrong. Okay, what is number 4? The entire organ. Lung. And then number 6 is the muscle that allows your lungs to inflate and deflate. Diaphragm. It's technically part of your skeletal muscular system, your muscles, but you would not be able to breathe without your diaphragm. Whenever you have a spasm in your diaphragm, what happens? Hiccups. All right, so that's the basic anatomy. So I just have a hunch that you guys are not going to have much trouble understanding the physiology. We will get into what types of tissues and cartilage compose these structures, but for the most part, that's it. Your immune system is systemic. It's body-wide. This is just in your head, neck, and chest. That's it. Sebastian, you want to hear a fun story? What's your ancestry, Sebastian? Puerto Rican. My ancestry is Norwegian. If you go back far enough in time, they were Vikings. And you know what Vikings did to try to torture a rival? They would tie you up like this, kind of like a cross. And they would take an axe and they would open up your back. And they would take an axe and they'd crack your ribs on both sides of your back. They would take your lungs, pull them out of your, while they're still attached to you, they would loosen them out of your body and flap them over your shoulders. You could still breathe for a moment. It's just, it was torturous. You're alive while they carve out your lungs and flap them over your shoulders. I forget the exact name of the process, but I feel like something wings, I can't recall. It's torture. Why else would you want to play patty cake with your rival? It wasn't exactly like a wedding ceremony or something like that. I'll find out. I'll figure the name. But have you ever fallen on your back, Sebastian? Yeah. Have you ever had the wind knocked out of you? Your lungs are more located on your back than your front. Just keep that in mind. What do you mean? You fell on your stairs? Yeah. Have you ever ran fallen on your stairs? No. Not like 3 in the morning and you're like running up your stairs. No. Well, I mean, you're always hurt, Emma. I've known you for about 8 months so far, and you've been hurt the whole time. It's the same injury. 3 months. You've been falling down your stairs at 3 a.m.? Oh, no. That was just hypothetical. Oh. All right. So, now that we have that out of the way, let's get into the function and the process of respiration in your respiratory system. The function of your respiratory system is to supply the body with what gas? With oxygen. What is the chemical formula for oxygen? I'm going to give you guys a mini chemistry lesson. I'm going to teach you why it's O2 and not just O, if you ever wondered that. And dispose of what gas does your body produce that it no longer needs? Carbon dioxide. And what is the chemical formula for carbon dioxide? CO2. Okay. If you've been at plant long enough, you know I've taught bio, I've taught AP bio, I've taught chem, and I teach anatomy now. So some of you may have been in my chemistry class. A lot of you, I don't think you were, but I think a few of you may have been. I want to give you a quick chem lesson as to why it's O2 and why it's CO2. Now, with the exception of hydrogen and helium, how many valence electrons most atoms have in order to be considered stable? 8. If you look at the periodic table behind me, oxygen is in the top row, element number 8. Oh, I love answering. Normally, when I answer like that on a girl's phone, it's the dad saying, "Where's my daughter?" $5,000. All right. As I was saying before the phone rang, here we go. So oxygen is an element with, it should have 8, but it only has 6. It's in column 16, so that means it has 6 valence electrons, and therefore it is not stable. 1, 2, 3, 4, 5, 6. 6 valence electrons. By itself, oxygen is not stable. So O does not exist by itself. It can't. You need another oxygen here. 1, 2, 3, 4, 5, 6. And you need to get them to bond together so that they can give each other a total of 8. This is called a covalent bond. Sharing is caring and caring is covalent. A lot of you live in a house with other people. You're able to live in the same house, use the same fridge, use the same couch, and coexist. Everybody gets what they need. It's just sharing. These two oxygens are going to share electrons with each other so that they're able to achieve an octet. So if you like chemistry, you probably like puzzles. So I'm going to move things around. So I'm going to erase this electron, put it here. I'm going to erase these 2 electrons and put them down here so it's symmetrical. I'm going to just erase this electron and put it there. Now, how many electrons does that oxygen have now? And how about this one? 8. That is a double covalent bond. Within one of those lines are 2 electrons. So you have 2, 4, 6, 8, check. 2, 4, 6, 8, check. It all checks out. That's O2. And now for carbon dioxide, how many carbons are there in carbon dioxide? When you hear CO2, how many carbons are there? 1. How many valence electrons does carbon have? It's in group 14. It has 4. And when you hear CO2, how many oxygen atoms are there? CO2, there are 2 atoms of oxygen. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So you have to get a little creative. I'm going to erase these 2 electrons. I'm going to put them here. Carbon still has 4. I'm going to erase this, put that there, erase those, put that there, erase this, put that there, and put this here. There we go. How many electrons does that oxygen have? How about this oxygen? And how about that carbon? These are 2 double covalent bonds. This is the molecular formula and the molecular structure for CO2. This is what we need. And this is what we dispose of. You are not a palm tree. You do not need carbon dioxide. If you were to keep too much carbon dioxide in your body for too long, your blood will become acidic and you could develop too much. You could suffer from a condition known as lactic acidosis. All right. Let's get into the 4 steps in which we get oxygen throughout our body. Providing the body with O2 and ridding it of CO2 is called respiration. Nate, I want to play a little word association with you. See what your head's at. Ready? Happy. Dog. You know, I've already interpreted from you. You deal in opposites. I did this with someone else earlier. I said day. They said wasted. I laughed. It was funny. So you're dealing in opposites. That's what that kind of is. All right. So let's keep going. College. Nathaniel.
Mark. No.
Oh, okay. Pulmonary.
Artery.
Darn. I was hoping you didn't do it. You didn't say what I hope you would say. When I taught you guys pulmonary, what organs do you need to think of? Do you remember?
Artery.
No? Lungs. So that's word association with that. You will need that for this unit. Whenever you guys hear pulmonary, you need to think lungs. Here's another word association. When you hear respiration, what gas is needed? Oxygen. What gas is removed? You need to know that you need O2 and you remove CO2 when it comes to respiration. So in other words, O2 goes in, CO2 goes out. Ever since you were a little freshman, coming out of middle school, Miss Lavender, Miss Roy, maybe I was your bio teacher in freshman year. Some of you are juniors now. I had you 2 years ago. Cell respiration takes place in the mitochondria, the powerhouse of the cell. Everybody knows that. It needs oxygen. It produces CO2 waste. That's what's happening in your cells, cell respiration. What happens to your tissues when they don't receive oxygen? They die. Do you know what that process is called? Necrosis. Very bad. Well, this whole process of respiration happens in 4 steps. And this is going to take us to the end of class today. We're going to do these 4 steps in the bell should ring by the time I'm done. Let's do these 4 steps. Number 1, pulmonary ventilation, AKA breathing. When Sebastian is falling on his back and he says, I can't pulmonary ventilate. No one says that. I can't breathe. But the proper term is pulmonary ventilation. There are 2 stages. The first is inspiration. Inspiration means you're inhaling. What gas are you, or let me rephrase that. When you inhale air, where is the air coming from? What do you call that around you? All of this. Bigger. Atmosphere. It's coming from the atmosphere, and where is the air going? Right. So inspiration, it moves air from blank to blank. Mackenzie, where's the air moving from? The atmosphere. And where's it taking the air to? The lungs. What do you suppose the opposite of inspiration is? Expiration. Sebastian, expiration. Air is going out. It moves air from where to where? That is correct. Moves air from lungs to atmosphere. The space between you all and me is considered the atmosphere. Whenever you take in a deep breath, that's the atmosphere. And then when you release it, that goes back into the atmosphere. All of this room is an atmosphere. Outside is the atmosphere. In your bedroom, when you're snoring, that's the atmosphere. Number 2, step 2, external respiration. Alex, you're a smart girl. If I preface step 2 with external respiration, because there's an external respiration, what else must there also be? There is an internal respiration, which will be step 4, but we'll get there when we get there. Alex, do you know what a catheter is? What do you see a catheter as? The urethra. You're allowed to say urethra in anatomy class. Is it just for the urethra? No. A catheter is a little tube. It often is put in a patient's urethra, so when they have to pee in the hospital, they don't have to get up and go to the toilet, they just pee in a bag. Well, basically a catheter is a tube of some sort that can go into any orifice in the body. If I put a catheter up your nose, looking at this anatomy here, could I reach your lungs? Yes. Alex, when your mouth is open, when you're snoring at home and you're catching flies, are your lungs directly connected to the environment or the atmosphere, if you will? If you're laying like this, technically, yeah. Your lungs are connected to the outside world. That's why we call this external respiration, because although it is in your lungs and in your body, it is still connected to the outside world. If I threw a pebble in your mouth, it could get to your lungs. It came from the outside world, but let's continue this. If I put a catheter or threw a pebble or whatever into your mouth or your nose, could I get to your bloodstream? No, that's internal. No matter how deep that catheter goes, it can't get into your blood. It can get into your lungs, but it cannot get into your blood. So external respiration, guys, is going to be the interchange or the exchange between lungs and the atmosphere. But now we have to identify like what part of the atmosphere, okay? So I'll help you out. Oxygen diffuses from blank to blank. This is deep down in your alveoli, your air sacs at the very end of the road of your lungs. Do you need oxygen or are you getting rid of oxygen? You need it. So it's coming in. It's diffusing from your lungs. I'll help you out with that part. What in your body needs oxygen? Like, yeah, one of you said everything. How does the oxygen get there? Blood. In external respiration, you have gas going from your lungs to your blood. This is where it goes from technically being in the atmosphere to in your body. When I say in your body, I mean your bloodstream, like in your body. You're inside your lungs. Yes, it is in your body. But think of this. Imagine this pen is a cigarette. Right now, I'm inhaling a cigarette. It's going into my lungs. So technically, my lungs are connected to the outside world. That's why we call it external respiration. On the other hand, we have CO2. It diffuses from blank to blank. Are we needing CO2 or are we getting rid of CO2? So where's the CO2 coming from? Your blood. Some of you get the hang of this pattern here. And then where is it being released into? Your lungs. Right. All right. Now, here's the catch, everyone. These two steps, steps 1 and 2, are the only ones that your respiratory system can manage. Anybody thinking, well, duh, Mr. Teacher, man, that we're on the respiratory system. I don't think it's the urinary system. Fair. But if I'm telling you now, the respiratory system can only handle steps 1 and 2, this is a 4-step process. What system handles the other 2 steps? Hint, hint, we're talking about blood, cardiovascular. Your respiratory system cannot work without your cardiovascular, just like your skeletal system cannot work without your muscles. So let's go to step 4. Or yeah, 3. Transport of gases. What transports oxygen and carbon dioxide throughout your body? Blood. Whenever you inhale anything, whether it's just fresh air outside, or if you put your face in front of a muffler or an exhaust pipe, or if you do, people smoke pot, they smoke heroin, people actually smoke meth, which is crazy. Vaping, whatever it is, asbestos. You inhale that, it goes in your lungs, and then it goes in your blood, and it goes everywhere, head to toe, everywhere. So whatever you put in your lungs goes everywhere. Case in point, you guys have either seen in real life or in a movie or a TV show someone getting high off of marijuana. That marijuana is going in your lungs, but when you feel that high effect, that's in your brain. How did it get in your brain? Blood. Went in your blood. So step 4, oxygen diffuses from blank to blank. Or I got that wrong. My bad. I was looking at the last step. Excuse me. Oxygen is transported from blank to blank via blood. Okay. Emma, how did you get to school today? Yeah, you.
My car.
Your car. Okay. The car is your blood. Your home is point A. Playing high school is point B. So here's A, here's B. Blood is the car. Where is oxygen coming from, and where is it going to via the blood? Where did it come from? Anyone? The lungs. And where's it going to? No, not the heart. No, the blood is the vehicle in which it's traveling. The blood is allowing it to go from A to B. A is the lungs. Where's it going? More specific. Tissues of the body. So Lance, when you said lung, or when you said heart, that's a partial answer. The heart is part of the body, so it's all the body, not just the heart. And then CO2 is transported from blank to blank via blood. You're getting rid of CO2, so where's it coming from? Tissues. And where's it going to, Sebastian? Lungs. Get rid of it. Then we have our 4th and final step. I'm trying to hustle so we can wrap it up today. As Alex said, there's an external and there is an internal respiration. This is in your blood. Oxygen diffuses from blank to blank. So when the oxygen is in your blood, where is it being deposited? Where is it being delivered? No, oxygen thing is in your blood. Your lungs allowed it to enter your blood. Think of it like this. The lungs are a train station. The oxygen is a passenger. The blood is the train. Oxygen arrives at the train station, the lungs, it jumps into the blood, the train. What is the destination of the oxygen? He said heart. That's not it. Tissues of the body. That's the destination. Tell me again, what happens to any part of your body, head to toe, that doesn't get O2? It dies. Last part, CO2 diffuses from blank to blank. Remember, you don't want CO2. Get rid of it. Where is the CO2 coming from? Tissues of the body. Where is the CO2 going? The blood. It's kind of like a prisoner exchange. You say, you give me the oxygen, I'll give you the CO2. Deal? And that's the exchange that happens between your tissues and your blood and your lungs. Okay, tomorrow we will continue the anatomy of the upper and lower respiratory system.